And then before we start, I just want to give a quick background about what AmeriCorps and Conservation Nebraska is and what we do. So Conservation Nebraska educates Nebraskans across the state about conservation issues facing their communities and provides them with the tools they need to improve their local environment. And we do this through locally led education efforts with community engagement, and the Common Ground program works with Nebraskans to address their local conservation concerns. And today we're going to be hearing from Tyler Williams. And Tyler is a Cropping Systems Extension Educator through the University of Nebraska at Lincoln. He focuses his teachings primarily on climate trends, forecasts and projections, and climate change communication. So without further ado, please let's welcome Tyler Williams.
Thanks, Barb. Appreciate it. And hopefully all of you can hear me okay. I'm going to go ahead and share my screen here, and then I'll explain a little bit about kind of what we have planned for today. And so most of these I typically do in person, so it's a little different doing them online, but we'll make sure that we make it interesting. And please feel free to type into the chat box in the Q&A box, and maybe Barb or someone can jump in and read those off to me if you have them. So just a little bit about myself. So yeah, like she mentioned, I work as a cropping systems educator. I'm based out of Lancaster County. I kind of serve Lancaster, Casanova County area, but I do most of my climate work any place across the state, and regionally, I'm part of some groups that are part of the North Central region too. So we get out and kind of expand a lot of what we do, and it's primarily in the climate and agriculture space. And so I give a lot of presentations to farmers and ranchers, work a lot with growers on reducing risk and losses to weather and climate. And so I kind of dabble in that space a little bit. My background, my bachelor's degree is in meteorology and climatology, because I wanted to be a storm chaser, but I figured out after about year 3 in college that storm chasers don't get paid. So I ended up have to go do something else. I ended up getting a master's degree in agronomy and kind of been focusing on ag climatology since then. And so I give a lot of presentations to groups that want to learn more about climate and environmental issues such as yourself. And then I also kind of give a lot of presentations to the other side, where I'm dealing, directly with farmers who want to, are worried about their land, maybe not necessarily the climate piece, but so they both kind of learn both sides. So I'll give you a little bit of some of the background on what I do, and but most of today will be talking as environmental issues relate to climate, just because that's what I am focused on. The first half will be on climate change, some weird nuances that come with climate change, and then also some extra environmental issues I know that Barb wanted me to touch on, as well as some issues that are important to Nebraska and to yourself. So again, feel free to jump into the chat box. If there's something here, we'll be able to ask all the questions you want as we get towards the end, if there's something that I go over pretty fast. But I always start off a lot of my presentations and ask people. It's a little different online. I can't necessarily see you, but I'll ask it anyway, and just think in your head of when you hear the terms climate change or global warming, what image pops in your head? What's the first thing when someone says global warming? What's the first image that you pop in your head? And I didn't create this slide. It came from Dr. Anthony Leisowitz from Yale, but I think it's a great way to start off. And I'm going to guess that most of you probably had some sort of image like this one. Probably an image of a polar bear sitting on ice. And so I can't see nodding heads or anything, but most of the ones that I've done, I usually get about 2/3 of the people that would agree that this is the image that they think of. And primarily because it's been the image that's been tied to global warming and climate change terms for so long. Initially, people thought that this was a great way to promote sort of people to care about it. So why do you care about climate change? Well, this is not a good sign, right? But it's really got tied to it. And I think it is, and to a lot of people, it's pretty distant. There aren't very many polar bears and ice caps around Nebraska. So if you're really focused and concerned about Nebraska and what's going on here, this might not resonate you. And so a lot of what I do is to try to connect why climate matters to people here, why it might matter to a farming operation or a community member. Sometimes the polar bear doesn't do it. Most people care about this. It's just, sometimes this is a little bit of a disconnect. So we try to connect that. Let's see here. Oops, going a little slow. There we go. Okay. So I'll talk a little bit about climate change beliefs. It's kind of interesting talking about how people view climate change, and some of these things you've seen and probably heard about. But I mentioned Yale a little bit ago, but Yale, they put out these climate opinion maps every year, and they look at nationally, how does each county break down in their opinion on climate change. And so this map here looks at the percentage of adults who think global warming is happening, and the color scale is the difference from average. So the average in 2019 across the whole US was 67%. Okay? That's actually down 3% from what they put out in 2018. So, which isn't terribly surprising for lots of reasons, but anyway, so the national average is 67%. And so as you can see, any color that's in the purplish color is less than that national average. The colors that are light green or dark green are above that national average, and the darker the colors, the further you are from that average. So the dark green colors are, up towards 80 to 85% of the people in that county think that global warming is happening. And then the opposite side, the really dark purple, closer to 45% of people that think that it's happening. So it'd be less than half. And so you can see where Nebraska falls. You can pick any county that you want to kind of see where it falls. Lancaster County actually is the high, where I'm located, is actually the highest in the state. But most of Nebraska, the average Nebraska is about 60% or so, give or take any given year. But you'll kind of pick up on some of the patterns within this map. And I'll show you another map that you may also recognize. And that's this map, right? So it's the 2016 presidential election map, where red is voting Republican and blue is voting Democrat, right? You've seen this map, and I don't know if this is exactly totally perfect, but it's a pretty good idea of what happened, I think, and we would all probably agree that that's probably how most people would vote. But if you look back to this previous one, you can pick out any county you want, and you will probably find that the pattern is nearly identical, right? And so this is just a prime example that climate change or global warming and the feelings or beliefs within it are directly and almost identically correlated with political views and political parties. They've looked at all the different things of science literacy, education, whatever, you name it. And the thing that aligns the most with climate change beliefs is the political parties. And yeah, as someone just mentioned, look at the reservations, okay? Look at where Hispanic populations are. Those areas, you see it. You look at California, some of the larger cities, those places are aligned. But I always find the reservations quite interesting. Another interesting place that you'll see is look at Alaska, okay? You'll notice Alaska typically tends to vote Republican, right? But if we go back to this map here, I clicked off of it, so we'll go back. You'll see that they're above the national average. And if anyone's ever been to Alaska, I've been to Alaska, those people are seeing directly the changes, of sort of the undeniable changes in their climate, because they are on the fringe of freezing temperatures, right? When ice, that critical temperature of 32 makes a big difference, right? Ice or no ice, they live and their livelihoods depend on ice. So there's a lot of interesting things that you can find in some of these maps. And you can see here, I've got just another set. So the map on the left is essentially the same thing as the first one, other than just looking at the actual value of global warming is happening. You can see generally people are, 67% on average, right? Generally, the people are favorable to thinking that it's happening. You look on the right side, and most people are under 50% on thinking that if it's caused by humans. So that's generally where people start to split. Most of the ag producers, if you want to I don't want to lump them all together, but generally think that yes, they're seeing changes. They know that. A lot of times where people split is what's causing it. Is it natural? Is it whatever it might be. It's a combination of natural or humans. That's generally where people tend to split. And so you can kind of see where people fall, and that's kind of interesting to look at some of those things. But I always try to, ask myself, like, how did we get to this point, right? If we know it's kind of politics and, we have information, we have all of these things, but, I think about 1990, 30 years ago, where did we get our information? I think I wasn't too terribly old then, but I know that Bob Geiger out when I lived around Holdridge area was our weatherman, right? That's where we got the news. Got it from NTV News, or the newspaper, the Holdridge Daily Citizen was our paper. And that was the only paper that anyone read, or our 5 radio stations. Most all of us got our information from the same place, right? We might not have all agreed with that information we were getting, but at least we were getting the same information for the most part, right? And so if we fast forward to 2020, you kind of know where this is going. There are a lot of places to get information. And I don't know how many of you watch Fox News and CNN. Most people don't, but I do. And would it surprise you to know that the information you get from either of those channels is not the same, right? The information you might get from one news station is not the same information you're going to get on the other one, right? You can sometimes get totally differing opinions and even pieces of the truth. And generally what I found is a lot of it is, probably accurate, but it's a very narrow slice of what is the whole story, right? But they know their viewers. They know what their viewers want to hear. They know what their viewers want to see. And that's what drives them to come and watch, right? And so they call that a little bit of like confirmation bias, which is we tend to seek out the information that we want to believe, or that pleases us, or that we think is, that we believe, right? We don't want to see or hear or read anything else that might differ from where we want to go. You'll see a lot of this in social media, Facebook and Twitter. And I don't know how many of you unfollowed someone in the last presidential election. I'm thinking probably everyone that's on social media unfollowed someone because of their crazy views on, again, one side or the other. Again, that kind of falls into, we're kind of narrowing the viewpoints that we typically see. And the news that you get, and a lot of people only get their news from social media, and you probably wouldn't be all that surprised either that the news you get in your social media feed is tailored to you. It's their algorithms that are tailored to the groups that you follow, the people that you're friends with, the stories that you read and click on. So you get more of those, right? So there are a lot of things out there that you might not see that other people see. And so one thing that I've come to realize in doing a lot of this is that people get completely different types of information. And you wonder why maybe they don't see or hear or believe anything else, because they don't ever see that, right? And they wonder, how could you not believe this? This is there. And so it's quite interesting how that works and how we get our information. So I always try to tell people to, if you can't stand Fox News, turn it on for a while and just at least nothing else, understand why someone that never turns that off might think what they do. And same thing for CNN. If you never watch CNN, turn it on for a while and just see what's going on there, and just to try to get the difference. I try to get the whole picture, see what's going on, just to understand where people are at. But there are things that people come together on, and they look at that. And there's, this is one of the maps, the percent of adults who support research into renewable energy. Almost everyone supports research into renewable energy. You look maybe in the places where they have oil, they might not necessarily want to go into renewable energy. Oh, excuse me. But you can see that there, that generally everyone's there. And so the reason for wanting renewable energy might be different. Some people might want it for a cleaner environment. Other people might want it for economic reasons or energy independence. Whatever the reason, there's a sort of a win-win thing there that I think that we can focus on and move forward instead of focusing on the things that we don't always agree on. So I'm just going to talk just a bit of here about global warming and climate change. I use the words interchangeably a lot because it's kind of how people talk about it. But I just want to explain just a little bit about the difference, and most of you could probably understand the difference. But I will show here is what you're looking at here is you're looking at the 5-year average temperature, and you're looking up in the corner here is the 1880 to 1884. If you look in the upper right corner, that's the 5-year average temperature for that period, comparing it to the 20th century average. So the average temperature from 1900 to 2000. So the average temperature from 1880 to 1884 compared to that 20th century average. So you can see the areas in blue that were below that 20th century average and the areas in red at that time that were above it. And so what I'm gonna do is I'm gonna hit play, and there's gonna be a moving 5-year period. And you'll be able to see sort of the cooler than average periods or the warmer than average periods in different parts across the earth. And so I'll let this play. You can see right now we're into the early 80s, or early 1900s. Now we're going into the, oh, excuse me, I messed up. Let's see here. There we go. The 1930s, you can see it picks up and warms up pretty nicely in the 1930s and the dirty 30s. But you can see we bounce around, sort of some warm, cold, and that's kind of how things normally happen, is you bounce up in cold periods, warm periods, and up. But you can see in the 1980s that things switch, right? All of a sudden, you don't get as many of the cold ups and downs. Again, this is, looking at the 5-year averages. You're taking a pretty good chunk of time and averaging it. And so you can see the last part of the century, and even if you go out to 2019 and the new averages, it's the same thing. This is what I tell people, this is what global warming is, right? As a whole, the globe is warming. There are places in certain times that are not warming. It's snowing today in Lincoln, right? That doesn't mean we won't end the year warmer, right? Or we're not warming, we're warming overall. And so that's what I tell people is kind of the difference, right? And so climate change are sort of the weird nuances that come from that. They talk a lot about, the map on the left is, if you have a warming Arctic, it changes the jet stream pattern, and it can influence how the waves move, and that can lead to places that get more precipitation or get colder temperatures or have really cold Januaries or cold Julys. A number of different things that might not be explained by global warming, but they can. It's a sort of an outcome because of the overall warming, right? It has other influences. Just like if you look on the map on the right, is our long-term winter average temperature in Nebraska over time has been on a pretty steady increasing trend, right? If we look at the last 120 some years, the pretty steady increasing trend. The last 30 years, we've seen a dip in that has cooled off quite a bit. A lot of that is to do with the month of February. And that is, as you look on the map on the left, is we get stuck in these cold patterns. And recently we've been stuck in that, the latter part of the winter, where we've been really cold. This year wasn't too bad, but the last number of years have been quite cold. And so that's decreased, right? But that's, I think, probably a short-term blip in our way up to keep increasing wintertime temperatures. But those are just some of the weird nuances that come with how complex the climate system is. It's not just as simple as we're just going to warm by 0.5 degree every year and keep trickling up, right? The globe might. I think there's over 440 consecutive months that the average monthly temperature has been above average for the globe, right? So the globe is consistently warming. Nebraska does a lot of this, right? And I don't want people to lose sight of the big picture when they see, a short-term cold pattern over certain months. So anyway, that's I like to just explain that, just to kind of get a difference of local impacts versus global impacts. This is just an example. They have lots of indicators to see that. The picture on the left is from 1941. Picture on the right is from 2004. A glacier in Alaska. We talked about how Alaska, those people might vote one way, but they're generally in more agreement on seeing climate change or global warming, and it's because the images like this. It's pretty hard to ignore. I've been a place where it used to be standing on a glacier, and then it was, standing in a river. So when you see that, you start to think, though, to look beyond maybe your previous beliefs, because it's pretty hard to ignore that. And so there's lots of examples of things like that you could use. So I'll go on here. So projections. So a lot of people want to know about projections, what's going to happen. Projections are primarily based off models. So they use models, and they set up this model, and they try to replicate what happened in the past. And so when they replicate what happened in the past, they can adjust how their models work, right? And they can compare it to what actually happened, right? So you can sort of use previous data to see if these models work correctly. Then what they do is then they project outward. And when they project outward, they use lots of things, and they have different scenarios based off of our emissions, right? And we'll talk in a minute a little bit about emissions and CO2 and greenhouse gases and that sort of thing. But the projections, they provide a range. So on that map on the right is looking out to 2100. You'll see that red line, blue line, yellow line, and green line. Those are essentially what they call representative concentration pathways. Okay? You don't have to really know what it is. Just think of the amount of greenhouse gas emissions. The red line is increasing greenhouse gas emissions at the rate that we're going now, right? So we're keep emitting from 2000 to 2100 at the rate we are now, right? So we're status quo is what they call it. That's what they call RCP 8.5. The green line is if we basically stop emissions instantly. So that's sort of the bottom, right? If we cut it off, don't increase anymore, that's what they call the RCP 2.6. And a couple of the other models are in the middle, right? So the range in the models that we have for projections are all based off of what humans do, right? So that's why you get this big range. And so it's hard to project exactly what's going to happen because you don't know how technology is going to advance or how humans are going to respond. So you get this range to try to give an idea of where we might be headed. And so there's a lot of uncertainty there. If we knew exactly which one it was, we could have a pretty good idea of how this would look. But you just don't know what policy will do, how humans will respond, all of those types of things. So, so if we go here and we look at the projections, right? So the map on the left is temperature projections, and the one on the right is precipitation projections. And so they give you the sort of the on the temperature side, they give you the mid-century and the late century. So by 2050, if we're looking at the temperature, is sort of those middle two maps. They're projecting using the lower, sort of the lower middle-ish scenario of about 2 to 3 degree temperature, 3 to 4 degree temperature increase for most of the U.S. That's by 2050. If you look on the right-hand side, that's looking at the higher scenario. So if we don't do anything about our emissions, they're even seeing a difference there in temperature by the middle of the century. And at 2050, to be honest, isn't that far away. That's 30 years away. Your kids will be, or if you're my age, my kids will be making these decisions in those sort of conditions. So, and the bottom is sort of by the end of the 21st century. So by 2100, you can see the difference in the lower scenario to the higher scenario on the right. And so that's kind of the range that we're looking at. We're not going to go to zero by most of these models. So there's still going to be some impact no matter what we do. And so if we look on the right-hand side of precipitation, they separate it out by seasons because there are big seasonal differences. And generally, it's the northern latitudes will get wetter. As we increase in temperature, it can hold more moisture. There's more precipitation that is able to be had. But if you look at the summertime, they're expecting decreasing precipitation. And the agricultural state like us, that's a concern because we rely on summertime precipitation to grow a lot of crops. I know we have irrigation, and we'll talk about that, but if we don't if we really significantly drop off rain, the irrigation, we won't be able to do that forever. So that's definitely something to consider. But the dots and the lines that you see on there, the dots are essentially increased confidence. So where they have dots, you can see they have high confidence in that trend or that projection. So northern latitude, winter and spring precipitation, there's pretty high confidence that increase. Where if you look at the summer and fall, there's less confidence. That's what those slashes mean, is less confidence that might happen. So nonetheless, the projection is for maybe a slight increase in precipitation overall, but it's the timing of it that's probably most concerning to people. So a little bit on the greenhouse gases. I mentioned that just a little bit as far as that's what goes into the models, but the upper left-hand picture, that's, our concentration of our atmospheres, 78% nitrogen, 21% oxygen, and 1% is where our greenhouse gases lie. So they're a very small percentage of our atmosphere. They include carbon dioxide, methane, nitrous oxide, ozone, water vapor. You can see those there. But there are heat regulators. They have properties that allow solar radiation in, but they trap some of that heat there, so they keep us warm. So without those greenhouse gases, which were discovered in like the 1800s, the greenhouse gas theory, or about 50, it'd be about 59 degrees colder if we didn't have those greenhouse gases on Earth in average, right? So Earth literally wouldn't be habitable without those greenhouse gases. So it's an important part of our atmosphere, but there's a balance there. There's a balance of, not letting too much in, or, not letting too much out, keeping the right amount in that keeps us at a balance. I mean, Earth is all about balance. And so that 59 degrees is pretty important, that we need to keep that. Because I'm cold enough already. I don't need to be 59 degrees colder. I wouldn't make it. But on the right-hand side, you can see sort of the contribution to the greenhouse effect. So what is the potency, or what's the power of each of those gases within the greenhouse, gas property, that 1%. And you'll notice that water vapor is actually the biggest contributor to the greenhouse effect. And I don't think a lot of people know that, or at least maybe not quite think about it instantly. But water vapor is the biggest component of the greenhouse effect. Carbon dioxide's, a quarter, ozone, methane, nitrous oxide, you can see some of those other there. I think sometimes people forget, and I think water vapor's there. I also think it's something that's underplayed when it comes to our warming trends and patterns, at least on the micro scale or regional scale of how we influence the water cycle. Doesn't matter if you're in a city, changing the evaporation from, concrete doesn't allow much to infiltrate, those types of things, right? Or on ag land and irrigation, how does that change our water cycle? So, increasing that water vapor also has, warmer tendencies to it. So, anyway, it's an interesting concept and stuff to think about. So I won't go into too much more on that, but I will go through a few of these greenhouse gases. And so, if we think globally, there are a lot of, greenhouse gases are everywhere, right? I mean, and our atmosphere is shared with everyone across the Earth. So if you look on the left-hand side, that's the global greenhouse gas emissions by gas. So if we think about what's emitted, carbon dioxide is 3/4 of that. And that's why a lot of times, carbon dioxide gets the bulk of the interest, even though there are other greenhouse gases, because at 3/4 of that, our emissions are greenhouse gas or carbon dioxide. Methane is 16%. Nitrous oxide is even smaller. Other F gases are smaller yet. Then the next one is, you can see this is just from 2014. This is global CO2 emissions from fossil fuel combustion and industrial processes. A bit pretty narrow, but you can see generally who the big contributors are to greenhouse gas production. China's roughly a third. The United States is 15%. The EU is 9%. India is 7%. So between China and the United States, we're 45%, close to half of greenhouse gas emissions, at least CO2 emissions from fossil fuels. So we're a big contributor. If those two countries themselves could significantly reduce emissions, that would make our global emissions much less, right? So we could have the biggest impact. And that's why, we take a lot of the fingers pointed at us in some cases, because we are 15% of all emissions. And if you look at per capita, we're pretty high too. China has a lot more people. So we're a lot higher than them when it comes to per capita. So that's, globally, that's kind of what it looks like. On the right-hand side, you can see those are carbon emissions from fossil fuels from 1900 to 2014. So you can see we're not really on any path that looks like it's going down, right? So there's nothing really pointing to those emissions dropping, at least significantly. And I think that's the concern that people have is, when are we going to start turning the curve on global emissions? And, I mentioned, I always put down there the Paris Agreement. So the Paris Agreement was put together for all the countries to reduce their emissions, right? To come to this agreement, say, yes, we're going to reduce those emissions. And most people didn't read the Paris Agreement. I did, because it's actually not that long of a read. The challenge was there really wasn't anything binding within that. Clearly wasn't that binding. We pulled out. Also, and it was sort of each country saying, tell us what you can do, and that's good. So countries just said, yes, we will do this. And then another thing in there was that a lot of those developing countries couldn't afford it. Okay? So if the cost of that was then put on the developed countries to contribute funds to help these developing countries reach their needs. So that was, I think, probably the biggest reason why President Trump pulled out of that, was because of the economic hindrance that it would have put on developed countries, and specifically the USA, to those developing countries. Sorry, I got a tickle in my throat. So there's a lot of interesting things that can go on globally. And so the next one looks a little more closer to home at the US. On the left-hand side, this comes from the EPA. They're a few years old now, but they haven't updated at least a lot of their graphics. But this is looking at greenhouse gas emissions by sector. Clearly, energy is the big one, right? Energy is the biggest emitter of greenhouse gas emissions. And these are based off of CO2 equivalent. So when we look at greenhouse gas emissions, we talked about all the different gases that are out there that can be emitted, but they kind of compare them to the potency of carbon dioxide. And I'll talk about how other gases have different heat trapping properties, but they're all based off CO2 equivalent. So this includes nitrous oxide, methane, and carbon dioxide. So it's all of those gases. It's just compared to a CO2 equivalent. The group that I work with, agriculture, agriculture is 9%. That doesn't pull out some of the energy use. That's what's in that. And that's probably the biggest challenge with, which sector is producing which is where does agriculture end and where does, food consumption begin? So I think that's kind of the biggest challenge of where to draw the line. Generally, agriculture is not a huge contributor from the whole greenhouse gas perspective. But if you look at nitrous oxide, agriculture is 77% of nitrous oxide emissions. And I'll go through a little more detail in a minute, and 35% of methane emissions. So even though as a whole might not be that big, but when those sectors, it's a big piece. And so, that doesn't include the CO2 sequestered by plants and forests. This is just strictly what's leaving, right? What's going out. On the bottom right-hand side, you can see the source of the ag greenhouse gases. So I've mentioned, at 9%. So where are those coming from within the ag sector? 30% are from cropland and soils. 12% are from grassland. So there's a lot of natural emissions from grassland. Energy use, enteric fermentation, which is essentially the cow burps and farts that you hear about. That's 95% of that is actually the cow burps. The manure management, we will emit some gases from that as well. And that's about 14%. So if we kind of dive in here to a few of these gases. So if we know CO2 is what we follow a lot, right? And that's measured officially at Mauna Loa, which is in Hawaii. So if you ever need a reason to go learn more about climate, right? We just take a trip to Hawaii. Maybe Conservation Nebraska can flip the bill and we can go. But you can see that the map on the left is looking at monthly measurements from 2016 out to 2020. This actually pulled this off in February, I think. But you can see the annual cycle. The greatest concentration of CO2 at Mauna Loa happens in about May. So we're actually coming up here where we'll be hitting May. That's because we're generally not taking any CO2 out of the atmosphere right now because plants aren't growing much, but we've emitted all winter long, right? But you can see when it goes down, the minimum is at about September or October. We don't go down as far as we did the year previous to that. And so that's kind of the concern is we keep increasing over time. And then you can look back at the map on the right is back to 1960 to 2000. We've increased a lot, right? And there's no real end in sight, at least for what we're doing now. They measure parts per million. Parts per million is just essentially an amount of something and a volume of something else. So 1 part per million is essentially 0.0001% of a volume as a part per million. I'll give you an example of that when we talk about nitrates in a second. But this is just an image. I was actually going through my first atmospheric physics book the other day, and it was a pretty old book. It came from the 70s, and they had a chart in there on Mauna Loa and the CO2 emissions, talking about how they were concerned about fossil fuel emissions and how that contributed to the atmosphere and the greenhouses or greenhouse effect. So it was just interesting that even in the 70s they were talking about it, but our chart went up to 335 parts per million in that one, and we're well over 410 now. So have to have a bigger chart in textbooks today. So carbon dioxide, that's 86% of all the greenhouse gas from human activities in the U.S. That's why we talk a lot about greenhouse gas or CO2 emissions. The chart on the right is the U.S. CO2 emissions. So generally, we've done a pretty good job of curbing our CO2 emissions. This is still a lot. but at least it's not exponential increase. I think when we get some more data for the 2017, 18, and 19, I think you'll see this number bump back up for a number of reasons: changes in policy, changes in fuel prices, those types of things. I think will bump that number back up. So, but generally over the long haul, we've been doing better here in the U.S. But CO2 is highly mobile. It can go in and out of the atmosphere really fast. I have a video here in a second that I can show you how fast that can go out. But essentially, plants are what take that out of the atmosphere. So what this graphic here you're going to see is looking at seasonal changes in carbon dioxide. I'll see if I can hit play here. There we go. But you'll see this starts in March, I believe. Yep, March. And it looks at the blue colors here have roughly 390 to 393 parts per million. So that's how much CO2 is in the atmosphere. The red is closer to 405 to 408 parts per million. And you'll notice that most of the CO2 is in the lower part of the atmosphere, but you'll see how the southern hemisphere is blue, right? So it's lower CO2 amounts in that part of the hemisphere because it's their growing season. The plants are actively growing. They're taking CO2 out of the atmosphere and lowering the atmospheric concentration. Whereas in the northern hemisphere, our wintertime, we don't have a lot growing. So we have a higher concentration of CO2. But you'll notice here as we get into July, August, and September, how the colors within the northern hemisphere significantly decrease. They drop by 20 parts per million just from plants, right? I think plants can be a key piece to taking some of that CO2 back out of the atmosphere. And the IPCC has said that agriculture may be one of the biggest opportunities to grow plants if we can do it correctly and pull some of that CO2 back out of the atmosphere, or forests or urban forests. We just know that we need plants, and that's the thing that can pull CO2 out the fastest. And so it's kind of interesting to watch and see how that CO2 moves in the atmosphere. When it comes to mitigation, so mitigation is essentially, reducing our impact on that, reducing how we influence greenhouse gas emissions. One way I know that they do that in agriculture is, like things like ethanol and biofuels. They can reduce greenhouse gas emissions compared to just straight petroleum-based fuels. So if you look on the left of, renewable fuels or biodiesel fuels, reduced by 50% the greenhouse gas emissions using that compared to a petroleum baseline. Or cellulosic fuels. I'm not as familiar with those, but they have a higher potential to reduce greenhouse gases. So there's just one thing in ag, and there's many other things that can come on the mitigation side. So for methane, I'm not going to go into as much depth as these other two, but methane it lasts on average 14 years in the atmosphere. So it actually doesn't last that long, but it's pretty potent, right? So its heat trapping properties are quite high. It's 25 times the global warming potential than CO2. So essentially, if you had 1 part methane, that would equal 25 parts of CO2. So you can see the concern why they would have with emitting methane is because of the global warming potential is so high. On the bottom right-hand side, you can see the source of methane emissions. I mentioned earlier, 30-some%, almost 40% is from agriculture, but you can see coal mining, natural gas, and petroleum systems emit methane. Landfills are a big contributor. That's one of the things that they talk a lot about. Composting is taking some of that out of the landfills. Enteric fermentation, manure management, that's where the agriculture sector comes in. They're doing things to reduce emissions. They try to increase animal productivity. There are places that they take the digesters and they use the gas from the manure and they help power the animal facilities. I know they do that at some dairies and other facilities where that. So it's some things that they're working on there. Nitrous oxide. Nitrous oxide is sort of the biggie, I think, especially when it comes to agriculture. It lasts on average 114 years. So it lasts a long time. It has global warming potential 289 times than that of CO2. Again, so one piece of CO2 would equal 1 piece of methane would equal 289 pieces of CO2. We emit a lot more CO2 than we do nitrous oxide, which is, I guess, a good thing. But nitrous oxide can be very potent and it lasts a long time. 40% of global nitrous oxide comes from human activities. A lot of it does come from natural processes, natural land that emits some of that nitrous oxide. But in the U.S., agriculture is the biggest, human emitter of nitrous oxide. And you can see that there in the image on the right. That comes from cropland. And it's primarily in corn, right? In corn production and nitrogen use in corn production. Ag's been working on a number of things to reduce that. They have nitrogen stabilizers that reduce those losses. They can apply in sort of nitrogen in season. And they can engineer crops to better use that nitrogen, use it when it needs it, and puts it directly to the ear so they don't have to apply as much nitrogen. So they've really decreased the amount of nitrogen they can put on. A lot of that has to do with engineering those crops. And that's kind of where I take a little bit of a turn here is kind of jump into, a little bit on, GMOs, right? I've got just one slide here on GMOs. I know it's one thing you wanted to mention, but how do GMOs fit in this whole scheme of environmental protection? How does it fit for adaptation and mitigation? Are they good or bad? You can see lots of things across the board, right? If you do a Google search of GMOs, you're going to get a range of information, just like if you Googled climate change, you're going to get a range of information and opinions. Generally, I think a lot of scientists think that GMOs probably are necessary to reduce the impact that we have on the environment. There are a lot of potential good things that could come out of with genetic engineering. Are they good or bad? I don't know if we have. We haven't used them for long term to know what the long term impact is on that. But they could reduce pesticide use. They can increase water and nutrient use efficiency. I think that's kind of the key one, especially in Nebraska. We talk about water and water quality and water use and drought tolerance. They can reduce crop losses and speed up technology advances. They talk about growing more with less, right? Most of that has to do with technology and genetic engineering. And so I think that's a space that a lot of people are looking at. I know they're really looking at a lot of it, especially in areas like Africa, where they really need some, they have the opportunity to use that technology to enhance their food production in places that they need it most. So I think that's a space that will probably grow just because of the potential for environmental benefits that could be there. So when I talk about water quality, water quality in Nebraska is really dependent on nitrates. Nitrates is kind of a big deal. So the map on the left is essentially are wells that have been tested over the last 20 or so years, and the nitrate levels that were in those tests. So the green is good. Less than 7.5, they say is okay. And they're based off milligrams per liter or parts per million. We talked about parts per million. Essentially 1 pound of nitrate nitrogen and 12,000 gallons of water is 10 parts per million, right? So if you think about what that looks like to how much, it's not very much. The yellow wells are the ones that are close to meeting that 10 parts per million. And that's the level that public drinking waters have to stay in order to keep drinking water safe. But you can see these red ones that are greater than 20 parts per million. That's high. And you can see the areas where these are at. And those are definitely areas that are in a lot of groundwater management areas. They're very limited on the nitrogen they can use and nitrogen they can put on. But a lot of that aligns with where our wells are, right? And if you look at these green dots, those are the irrigation wells, and those are primarily for crop production. So you can see where most of the crop production is. Along the Platte River is where you saw a lot of those high nitrate levels. Up here in the Brazil watershed area, you don't have to go very far down to groundwater to these. There's a lot of sand here, right? So you can quickly get some of those nitrates down into that groundwater. And so that's the biggest concern in some of those areas. But you get in some of these other areas, eastern Nebraska, there's still plenty of wells that are that were on that last map with having high nitrate levels. So you can see some of the public water wells, domestic, you see livestock up here. But anyway, you can see we have a lot of wells in Nebraska. We have a lot of groundwater. I think the next map, shows our groundwater level changes. The areas in yellow have declined. They call pre-development. I don't remember how far back they go in pre-development. It's probably even on this map somewhere in the fine print. But I know they go way back. I think it's like the 50s, before really irrigation became a thing. And you can look at where water levels have increased and where water levels have decreased. And generally, it's in the areas where we're growing crops where it's decreased. but you notice the ones that stick out, southwest Nebraska and up in Sheridan County, up in northwest Nebraska. There are a lot of irrigated farm ground up there. You get areas out west, they just don't replenish groundwater as well as we can do in the east. They just don't get the rainfall to recharge, right? So they have concerns with groundwater levels. We've had, the last couple of years, we've had some decent rains, and that's helped. But you'll notice some areas in the state have actually increasing groundwater levels, and there's a lot of hydrologic things going on there. There's a lot of man-made structures that are built within that also help that. But generally, as a state, we're lucky. You look at Kansas, Oklahoma, and Texas, they're basically all red when it comes to long-term groundwater levels. So, but nonetheless, this is a resource that we have to protect from a human use standpoint and from an agriculture standpoint. It's definitely something that we want to keep an eye on. So we talk about soil erosion. This is just a map showing you the red dots are wind erosion and the blue dots are water erosion. And each dot represents 100,000 tons per year of soil loss. Okay, so that's a lot. So each blue dot represents 100,000 tons. Each red dot's 100,000 tons of wind erosion. So you can imagine how much soil can be lost. That's one of the concerns in Nebraska we have is keeping soil where it belongs, not in the rivers, not in the bottoms. We need our topsoil to grow productive ground. And so one of the big things we've been working on is protecting that soil, because that's where we grow all of our plants, whether it's no-till production, cover crops, putting ground back into grazing. If you look out in the sandhills, there's not much erosion. If we can keep the grass covered or the soil covered, we're sitting in pretty good shape. So just a concern there. But all these are impacted by our weather and climate, and that's why I talk about them a lot. It's why I do what I do. They're all in one shape, form, or fashion influenced by that. Changes in our climate will influence some of those impacts we have on our state. So we always talk about, like, what can we do about it? What can actually be done? And I can always kind of go through these 4 steps of what we need to do to make changes, right? We have to rely on technology and science, at least something, right? So we have to understand kind of what's going on, what the problems are, understand what can be done about it, what technology we can use to change that. We're still going to keep increasing global population. And so we have to figure out how we're going to do more with less, right? We're going to have less land, more people, all those things, right? And then we kind of go into the planning stage of taking that understanding. And I like to use scenario planning. So planning for different types of scenarios that might happen. Maybe know exactly what it is, but let's put it in a plan and see how that might work. We have to agree, right? In order to get anything done, and you see that in legislature and Congress and all that, people don't agree, nothing gets done, right? And that's even with your spouse, maybe, right? If you don't agree, a lot of times nothing can get done, right? And so we can focus on some of the win-wins, right? So what 2 things can both sides agree on that we can accomplish and we can move forward on, right? That's progress, right? So we have to agree on what we're going to do, and then we have to do it. One way that we're doing things is we have this Weather Ready Farms program that looks at all of the practices that we recommend, right? So we've used science to say this helps. We've planned for all of the risks that are out there on farms and primarily in eastern Nebraska. And we kind of agree amongst science and amongst farmers of, yes, these are the things that we need to do. And so we use this Weather Ready Farms program as a way to kind of manage that, right? Who's doing what? And can we reward those producers that are doing things that we think are good for society, but also maybe good for the farm? So just kind of, things that we need to go through to process to actually make those changes. And the biggest thing that I can say, and I tell the people when I work anyone in agriculture, is to focus on the soil. Most of the risks to agriculture, or really a lot of what we do, can be solved by focusing on the soil. When it comes to heavy rainfall events or flooding, if we can infiltrate more of that water, that's less runoff that hits the Missouri River that then floods Omaha or Plattsmouth or whatever. We sequester carbon. We can keep a lot of carbon in the soil, put it back to where it came from. We grow roots that puts carbon down the soil. Lots of things, so the soil can be the key to a lot of the issues and challenges that we talk about. Filtering out nitrates and water holding capacity, all of those things are good things that are beneficial to the state. So a lot of what I do is focus on that. And I think in general, things that we can do policy-wise, all of those that better the soil, I think it's better for all of us. So I took a lot longer than I had planned. Anyway, so that's the last one I had. I want to pull up the chat box. I kind of stopped. Maybe I'll just go back to that, leave that one up there. I stopped looking at the chat box. I kept clicking off and it was messing me up. So I'll just look at some of the questions. Someone, I think the dead tree, I did see that one. That was looking at what images do you think of? And yeah, the Pine Ridge, Rosebud reservations, those I think was referring to the climate change beliefs. And so, yeah, the reservations were key on that. So I think the observations that was kind of go along there. North central U.S. cooling and more moist. Yeah, so generally that's kind of the pattern is overall the U.S. or the north central U.S. is actually warming as a whole, but our spring times and our summers are cooling and wetting. We get to the latter part of the summer and the moisture starts to cut off. So a few things in there, some comments, wheat, right? I try to get people to grow wheat and no one wants to grow wheat because you don't make any money. Until wheat can make some money, people aren't going to consistently grow it. Most of them grow wheat as sort of an alternative, right? To enable to put in cover crops so they can graze it or a place to put manure if they have animals. Generally, people don't grow wheat to make money. And then now it's a hard sell because people still have to make money. Question of what are the percentages per capita? I think that was on emissions. Per capita, the U.S. is by far way and above, right? We have 300 million people and 15% of this was I think the global green or the CO2 emissions. China was at 30%, but they have like a couple billion people, 1 billion people. I don't even know what that is. So yeah, we're much above when it comes to per capita. So yeah, the NASA maps, emissions, yeah, January. So this recent virus has really cut back on driving, has cut back onto what we're emitting, cleaning the air. That's a big thing I think people are going to look at. And a lot of folks in the climate realm are thinking, what can we do when we try to get back out of this thing that we're in? How can we adjust what we do to align with where we need to go, right? I saw an article that people in India for the first time saw the Himalayas, Himalayan mountains, because the air was finally clean. It should be just light bulbs going off all over of, how can we get back to work, get back to manufacturing, doing our things that we know needs to probably be done to do what we need. How can we do that differently to see the benefits that we're doing now? Question, do you think we'll have to use heirloom seeds to adjust to climate changes? Maybe, or technology. If we think about, what's worked in the past, get back to some native species, those have a lot of promising advantages to what we need to do. So, but I think technology will be a big piece of that to the point at which it's allowed, right? And I talk about GMOs of regulation and what's safe. There's that unknown of changing, what we're planting, what effect does that have on humans, on us? I think the unknown of that will slow down technology. So I think it'll be kind of a combination of both of those things to actually, what I think will actually happen going forward. Question of what response do you get when you talk climate to farmers west of Lincoln about climate? I don't even have to go west of Lincoln. I go in Lincoln. I can go east of Lincoln, south of Lincoln. It doesn't matter. Generally, farmers are I would say more on the conservative side of believing climate change. Most all of them agree with the changes, right? They don't argue with the data that I show on the changes that we've seen. The strongest opinion is that it's not caused by humans, right? That there's all these natural cycles. Humans might have a small role, but it's the natural cycles that are more dominant in this. And they compare it to historical climate. And historically, yeah, so our historical climate's different, right? Our Earth is pretty old. We've been through lots of different climates, right? Climates change. They don't change at the speed at which our climate is changing, right? And we're sort of adapted to this one. Lincoln how many years ago, a long time ago, was covered by glaciers. We wouldn't be here if we were covered by a glacier. At least I wouldn't. I don't like the cold, so I wouldn't be here. So we're adapted to this climate. So yes, climate has changed for over time. Yes, that's happened. But we sort of we need this climate to be like it is, right? That's what we need time to adjust and change. So farmers, again, they don't argue with it. The projections, they don't say too much. Generally, when I talk about it, I really get any kickback or feedback, at least negatively. Most of it is, what about this or what about that? But generally, it's the causes of it. And I don't think they have a ton of confidence in doing changes to prevent emissions that wouldn't be catastrophic economically. And I think that's kind of what we see now, right? We see what it's taken from our economy in order to get clean air. But I think there's something in the middle there that we have to do in order to progress to that. So the next question is nuclear energy a possible solution? That's one that gets brought up a lot, and I'm not an energy pro. A lot of people bring up nuclear because of the how we have it already, right? It's not, it's relatively consistent. One of the big things that we talk about with solar or wind is sometimes the consistency of needing it right now and all the time. Wind dies down, sun goes down, those types of things. We get better batteries and ways to store that energy. That probably won't be as big a problem. But yeah, I hear a lot about how nuclear can be one of the bigger solutions when it comes to having energy going forward. So I don't know a ton about the nuclear energy process, other than I know that's one that gets touted a lot. So I don't know if you have any more questions, again, feel free to, I'm going to stop sharing that there. Then I can see if there's anything in the Q&A box. Doesn't look like there is. Or if I missed anything in the chat box, go ahead and put that in. Again, if you have other questions or want me to go back and look at another picture. I had my Twitter handle on there, Tyler W_UNL. I put a lot of information on Twitter. That's kind of where I kind of keep things relevant. Most of it is directed towards agriculture in some form or fashion, but it's a pretty good way to reach the agricultural community, and so that's usually where I put it. But we have, I work a lot with the State Climate Office, and we have a number of things that we put out when it comes to climate monitoring and things like that. Oh, okay, there are a couple questions. One for Mike. Hi, Mike. So a question here of what factors will most cause agricultural producers to make changes to address weather change or global warming? What I've learned is that in order to get people to change, they have the risk of not changing. The risk of not changing has to be higher than the risk of doing that change, right? So in their head, I don't want to put them all in a big lump, but in their head, they have to think, I need to change or else it'll be worse if I don't. So that's different for every person. Sometimes that's environmental pressure. Sometimes that's, the neighbors doing it, right? All of a sudden, you're the only one not doing things. That's going to pressure you to change, right? There's a social risk to that. There has to be that economic risk, right? If you're losing money or losing soil over and over again, and all of a sudden you have, let's say, someone coming to you and be like, you're losing all your topsoil, your production's going to go down. There's that risk, right? We talk about growing wheat. Wheat may not be economical, but you might have to diversify your farming operation. You might have to spread the workload, those types of things. So they have to perceive that risk of not changing to be higher. So another question there is follow up of discuss what nations are taking the steps and demonstrating best practice to make sustainable changes. Be specific on the producer steps as well as the policymakers' incentives. Okay, so I'll talk about what nations. I did some work in Europe with the Czech Republic. Europe is doing some things when it comes to conservation. I know that England had proposed taking a lot of farm ground, some of the poorer farm ground, big chunks of it, and putting it into like a conservation program, right? So just taking, I think it was something like a third of their land. This was proposed, but taking like a third of their farm ground and putting it into essentially grassland, knowing that lower productive land isn't as efficient, right? And that's usually the first farm ground that fails. So I think Europe is doing quite a bit. There are likely other countries that are doing practices that are sustainable. We're doing some things, just we have a lot of policies in place that don't necessarily help that. So then the next question on specific on the producer steps, as well as policymakers, incentives and disincentives and discounts. There's the producer steps can be depending on where you're starting or where you're coming from. Like I mentioned, the biggest thing is focusing on the soil. Anything we can do to help producers enhance and protect their soil from a policy side, incentive side, discounts and crop insurance, those types of things that can encourage producers to focus and invest in their soil are critical, I think, on farmer sustainability, but also and sort of the greater good, right, of reducing runoff, you're reducing erosion. Anything we can do to enhance that, whether that's policy, whether that's, like I said, incentives through insurance discounts, whether it's bankers giving discounts on loan rates, whatever it might be, to incentivize those producers to do that, to make it economical. Right now, the system we're in doesn't necessarily incentivize people to invest in the long term, because you're worried about, in 2 years, am I going to be farming? And so some of that makes a difference. So hopefully that answered your question a little bit. You might be able to throw in some things in the chat box too, if you have some comments. Next question was, are you talking up cover crops? And absolutely. So when we talk about carbon sequestration, no-till is great for adding carbon to the soil, but the level of what you can actually take in from a whole system is quite low. The only way that we can consistently add carbon to our soil and taking it from the atmosphere is having something green growing all the time. I always like to say mimicking Mother Nature, right? Mother Nature keeps it pretty covered most all the time. So cover crops are big. Cover crops might not make sense economically in some places in the short term, but I think the long-term goal of building up to that place where cover crops sort of becomes our third crop. In Nebraska, it's heavy corn, soybeans. It would be corn, soybean cover crop as the rotation, right? So it's a third crop into it. But yeah, definitely talk up cover crops just because of the potential many benefits that are out there when it comes to the soil. I don't know if there's any other questions that are popped up here. I don't see anything. And Barb, I don't know if there was other stuff you wanted me to cover that I didn't. I'm sure I successfully put everyone to sleep, and so they might not be back awake yet. But you have, like I said, you had my Twitter handle, my email. I'll put that in the chat box for you all to have. If you have any comments or want to send me, any questions or anything that comes up later on, feel free to do that. Phone isn't necessarily working all that well right now because who knows where I'm at with this distance working. So I'm happy to share any information you want. So Barb, I don't know if there's nothing else or if I covered anything else. I know you had might have had a poll or something. I don't know if you were pulling that up here or if you were going to send that out later, but that's all I have.
All right, Tyler, thank you so much for taking time out of your day to give this presentation. It was amazing. I know a lot of people appreciate it. We're getting a lot of great comments, and that is everything that I had. You covered everything and more. So again, thank you.